Hello, I am Seema and welcome to my chemistry videos. This is a special video for class 10 and this is a topic that I've chosen from the first chapter, which is chemical reactions and equations. And in types of reactions, the last type of reactions, that is oxidation and reduction reactions, is what I'll be telling you about. I'm making this video specially today for a child who has requested to know about this topic. Let us come straight to the topic. The different types of reactions that you've studied are the combination reactions. In combination reactions, you have two reactants or more than two reactants, and they combine to give you one product. So any reaction which you see where you find two or more reactants resulting in the formation of a single product, that is, it means that those reactants combined to give you the product. So such reactions are known as combination reactions. The next is decomposition reaction. A decomposition reaction is the opposite of a combination reaction. Combination is formation of a thing from little parts, and decomposition is breaking up of a large thing into smaller parts. So when you have a molecule in the reactants which is breaking down into smaller molecules, that kind of a reaction would be a decomposition reaction. The third type of reactions are displacement reactions. Displacement means I'm standing here and all of a sudden I find you and you want to take my place. So you just push me away from my place and you come and stand here. So what did you do to me? You displaced me from my position. So a displacement reaction is where one of the substances comes and takes the place of another one, thereby pushing it away from its position and taking its position. So that would be a displacement reaction. A double displacement is, again, a displacement is taking the place of another. But a double displacement means there's an exchange. There are two substances or atoms in two molecules. This atom from this molecule comes here and takes the place of this one, and this one goes and takes its place. So they exchange places. So you go to a show and you are with your friends and you suddenly find that that friend you would rather sit with her and you are the best friend with that person, and the second person who's sitting here is the best friend with the person who's sitting next to you. So what would you like to do? Would you like to just shift your positions, exchange positions? So you would go with your best friend. That person, if she takes your place, she would be sitting with her best friend. So that is a double displacement. The displacement took place twice. So these were the four types of reactions which I hope you've already studied. The idea of this video is to discuss oxidation and reduction reactions. Oxidation and reduction, these definitions, the first definitions that were given about oxidation and reduction were based on any reaction in which oxygen was added, or to any reactant when oxygen was added, it was said to be oxidized, and the opposite of oxidation was said to be reduction. Slowly, as we started studying and understanding oxidation-reduction reactions, we found that there could be many different ways how oxidation and reduction are actually occurring, but they may not involve the presence of oxygen at all. So there are now 7 different ways how you can differentiate between oxidation and reduction reactions. I'll give you these 7 definitions and then I'll explain them to you. Okay, let us take what is oxidation and what is reduction. The first definition of oxidation is that oxidation is the addition of oxygen atom. When oxygen adds to a reactant, we say that reactant has got oxidized. Remember, whenever we are talking of oxidation and reduction, we are talking of the reactants. When we were defining all types of reactions, what were we talking of? We were talking of what was happening to the reactants. So when you talk of oxidation and reduction also, you're always looking at what is happening to the reactants. Unless the question asks you to move from the product to the reactant. That in the products, if the reaction was occurring in the reverse direction, what would be what would be oxidized or what would be reduced? But in that case, you would actually mentally be flipping the reactants with the products. The products will become the reactants and the reactants will become the products. But let us first come back to this. Any reactant to which oxygen is adding is said to be oxidized. And any substance, the opposite I told you of oxidation would be reduction. So if addition of oxygen is oxidation, reduction would be removal of, oxygen. Reduction would be removal of oxygen, right? Oxygen atom. Because in the molecules, the oxygen, you're only looking for oxygen atoms. So addition of oxygen is oxidation and removal of oxygen is reduction. There was another definition given very in the beginning when there was no oxygen involved, yet the reaction was a redox reaction. So how would you define? Then oxygen is a negative atom and hydrogen is a positive atom in comparison to oxygen. When you study the last chapter in class 10, that is the periodic classification of elements, that is when you would be able to understand this better. But right now it is enough to know that oxygen is negative and hydrogen is positive. So if addition of a negative thing is oxidation, hydrogen is positive. If I have to define oxidation reduction in terms of hydrogen, I would say the second definition would be removal of hydrogen is oxidation, right? Removal of hydrogen is oxidation. Therefore, what would reduction be? Reduction would be addition of hydrogen. So we've got two definitions of oxidation and reduction now. Addition of oxygen is oxidation and removal of oxygen is reduction. Removal of hydrogen is oxidation and addition of hydrogen is reduction. Now we can sometimes talk, as I told you, that oxygen is negative and hydrogen is positive. Hydrogen is very similar to metals in the periodic table, that is in all the elements. And oxygen is a non-metal and is similar to other non-metals. So we can expand our definition of oxidation and reduction, because in many chemical reactions which are redox reactions, oxidation reduction reactions are also called redox reactions, where RED is for reduction and OX is for oxidation. So redox reactions. So in many reactions, redox reactions, we observe that neither oxygen nor hydrogen is present, yet oxidation and reduction are occurring. So how would you define, how would you identify what is getting oxidized, what is getting reduced? So the third definition that was given in terms of their nature was that, let us take it with oxygen. Oxygen is negative and non-metals are negative. So non-metals will show behavior which very similar to oxygen. So addition of non-metal would be oxidation. So the opposite of this would be removal of non-metal would be reduction. Addition of non-metal is oxidation and removal of non-metal would be reduction. So since they are opposite processes, what would you write in terms of metals? Hydrogen is similar to metals. So removal of hydrogen means removal of metals. So the fourth definition would be that removal of metals is oxidation and addition of metals then would be reduction. Right? So these are four definitions. For class 10, you would only be using these four definitions, right? But let me just give you three more definitions because these are what you would be using in class 11. And it's just an expansion of the same, you know. All metals are electropositive in nature. I told you hydrogen is positive and oxygen is negative by nature. So non-metals are negative by nature and metals are positive by nature. So what do we see? We can move to another definition from here, because metals and non-metals, oxygen or hydrogen, we also have elements in the periodic table which are metalloids. They fall between metals and non-metals. So they still show redox reactions. So how would you define? So you need another definition for that. So in that way we came to the next definition. We said when you have two atoms, one of them is bound to be a little more positive than the other one, and the other one is bound to be a little negative than the other one. So when we say this is negative, this is positive, we call them electropositive or electronegative. So their electronegativity or their electropositivity. So we say that the fifth definition would be that an addition of electronegative atom. The addition of an electronegative atom, because we said negative, anything which has negative charge, which is partially negatively charged in comparison to the other one, addition of the electronegative atom would be oxidation, and the opposite is removal of electronegative atom would be reduction. So if this is electronegative, you would see the opposite in electropositivity. So the next sixth definition would be removal of electropositive atom. Removal of electropositive atom would be oxidation, and addition of electropositive atom would be reduction. And the final definition here is the seventh definition. You know, the charge of an atom is studied in terms of its oxidation state or oxidation number. The higher the oxidation number, the more positive it is, it means the more electropositive the atom is. And the lesser is the oxidation number or the oxidation state, it means the more negative it is. See, you have integers from 0, 1, 2, 3, 4. So as you're going up, the value is increasing, the positive value is increasing, and as you come down, the negative value is increasing or the positive value is decreasing. So we say in terms of oxidation number also, oxidation leads to an increase in oxidation number. The oxidation number is the positive charge. So the increase in oxidation number, that is the apparent charge, is said to be oxidation, and a decrease in oxidation number would be reduction. Now, increase in oxidation number means that the charge is increasing, the positive charge is increasing on the atom, and decrease in oxidation number means that the positive charge is decreasing. Whenever chemical reactions occur, it is only electrons which get transferred. So what is happening when charge is increasing? When positive charge is increasing, it means the atom is losing electrons. So that gives rise to the next definition of redox reactions. The eighth definition, increase in charge occurs when there is a loss of electrons. When an atom loses electrons, it is said to be oxidized. And when an atom, on the other hand, gains electrons are added, it is said to be reduced. So there are different ways how oxidation and reduction reactions, you can judge in a reaction using these different definitions what is actually occurring, and based on these definitions, you decide which substance is getting oxidized, which substance is getting reduced. Now, as I told you, for class 10, we are only going to use these four definitions. That is oxygen, hydrogen, non-metal, and metal. These are the ones that we will not be dealing with. But remember, when you're solving a question, you may apply just one of these definitions, or sometimes you may require a combination of two or more definitions to see, rather only two, because there are only two components that you're seeing, what is getting oxidized, what is getting reduced. So you could define those, or you could identify those using these different definitions. So for the same equation, you may use the same definition sometimes, but sometimes it's not possible to use the same definition. So there we depend on more than one definition. This will become clear to you when I start solving the problems on this. So let me just write down a few problems, a few equations whose oxidation we would identify what is getting oxidized and what is getting reduced. Besides, there is one more concept that has to be introduced here, that if there is something that is gaining oxygen and it is getting oxidized, there obviously is another reactant present which is giving it that oxygen. So the substance that is giving it that oxygen must be the one that is getting reduced. So the substance which itself got reduced in order to oxidize the other substance is oxidizing this. So this one is called the oxidizing agent. The one that caused the oxidation is the one that itself got reduced, would act as the oxidizing agent. Let me take these examples and explain it to you well. Okay. So now I have written out a few equations and we'll see what is getting oxidized, what is getting reduced, what's the oxidizing agent, what's the reducing agent. This is very easy and this is the fun part. Now that you know the definitions, what is oxidation? Oxidation is addition of oxygen and removal of hydrogen. Addition of non-metal, removal of metal. If you remember just these 4 definitions of oxidation, you would remember the opposite of each one would be reduction. So let us start here. Here we have copper oxide reacting with hydrogen, and this is a sign of heat. When you heat these together, it results in the formation of copper and water. Now, if you see, you will look at the reactants and you have to trace the copper is present. Now, what were the definitions? Removal of oxygen, addition of hydrogen. So wherever you have oxygen or hydrogen, they are the things that you will not focus on first. You will first focus on the atom which is not oxygen or hydrogen and trace it from the reactant to the product. So we see copper here is present and you would prefer to use an upward arrow for the first reactant and downward arrow for this. So copper oxide is turning into copper. So what did I do? I traced copper. And when I trace copper oxide to copper, the atom copper, what do I see? Copper oxide became copper. It lost the oxygen. So I would put here that a minus O. It lost oxygen. If it lost oxygen, anything that loses oxygen is getting reduced, right? Loss of oxygen is reduction. So copper oxide is getting reduced, and what happens to the other reactant now? Whenever you have 2 reactants, I told you, if anything is getting oxidized or reduced, there has to be another person who is doing it for that. If the oxygen was removed from copper oxide, there was somebody who accepted that oxygen. That substance that accepted the oxygen would have gotten oxidized. So what accepted the oxygen? Hydrogen accepted that oxygen. So we see here that hydrogen became water. So what happened to this? It added oxygen. If it added oxygen, it means hydrogen got oxidized. Right? Who caused the reduction of copper oxide? Who caused the reduction? Would copper oxide have been reduced if there was no hydrogen to accept the oxygen? There has to be, reactions always have to be balanced. So if somebody is taking away something from copper oxide, that somebody or something has to be there. So the reduction of copper oxide was caused by hydrogen. So hydrogen would be called the reducing agent. It caused the reduction. So it is the agent who caused the reduction. So we say hydrogen is the reducing agent. And who caused the oxidation of hydrogen? Copper oxide. If copper oxide had not given the oxygen, could hydrogen have been reduced? No. So we say copper oxide here is the oxidizing agent. So what do we notice from this? That anything which gets reduced acts as the oxidizing agent, and anything which itself gets oxidized acts as the reducing agent, right? So your first step would be to identify who is getting oxidized, who is getting reduced. The one who is getting oxidized is the reducing agent, and the one that is getting reduced is the oxidizing agent. Come to the next problem. H2S plus chlorine are giving us sulfur and 2HCl. Is there oxygen in the equation? No oxygen. So we are going to rely on the second definition, hydrogen is present. So we'll rely on the second definition of hydrogen. So let us trace. Now, whenever I said what will you trace? You will trace the atoms other than oxygen and hydrogen, the one that you are using for definition. You will not trace that one, you will trace the other atoms. So I'm going to trace sulfur here. Sulfur is going from H2S to S, right? H2S to S. Sulfur is changing from H2S to S. So what is H2S losing? H2S is losing hydrogen. So loss of hydrogen. It shouldn't have been. I shouldn't have written molecule. It is atom. Right? Now, the loss of hydrogen atom, even if it is H2, these are actually two individual atoms. They are not a molecule. So it would be wrong to write H2. We only write H. It is losing hydrogen. If it is losing hydrogen, it means gain of oxygen and loss of hydrogen are oxidation. So H2S is getting oxidized. And who is accepting that hydrogen? Chlorine here is, you see, forms 2HCl. It means it is adding the hydrogen. The hydrogen is adding on to chlorine. And addition of hydrogen is known as reduction. So go back. This would be H2S is oxidized. So it would be the reducing agent. And chlorine is getting reduced, so it would be the oxidizing agent. Do you observe that whatever is reduced or oxidized, whatever is oxidized, or these have to be the reactants that we are talking of. We are talking of the reduction and oxidation of the reactants. There is a problem where the products were mentioned, so this point would be clear to you. We are always talking of oxidation and reduction of the reactants. If in a question you are asked an opposite reaction, in your mind you will actually be flipping the reactants and the products, because the reaction would then be moving in the backward direction, which means it is the products have become the reactants and the reactants have become the products. But we will not go into that. Let us just follow these. So oxidation, H2S was oxidized, chlorine was reduced, and anything which oxidized, who is oxidizing it? The oxidizing agent is oxidizing it. Chlorine is reduced. Who is reducing it? The reducing agent is reducing it. So the reducing agent, in order to reduce this, should itself get oxidized. And the oxidizing agent, in order to oxidize this, should itself get reduced. Right? Again, to make it more clear, for reduction means addition of hydrogen. Could reduction have occurred unless H2S donated the hydrogen? So for the reduction of chlorine, H2S had to get oxidized in order to give that hydrogen for its reduction. So that is how you identify these. Let us come to the next problem now. Now I'll move faster. I think you would have understood what I was trying to tell. We'll only move to the definitions and identify the reducing and oxidizing agents. Zinc oxide and carbon. Let us trace zinc now. We see there is oxygen, and which definition will we be using? Loss of oxygen, gain of oxygen. So zinc oxide is getting converted into zinc. It means it is losing oxygen. Losing oxygen means it is getting reduced. Carbon is gaining oxygen. So it is getting oxidized. So whatever is getting reduced is the oxidizing agent, and whatever is getting oxidized is the reducing agent. Next problem, MnO2 plus 4HCl gives you MnCl2 plus Cl2 plus H2O. You know now what is happening? There are three products. So this may tend to confuse you a little. But again, I told you, what do we have? We have both hydrogen and oxygen. And therefore, our definitions could include two definitions, that is, in terms of hydrogen and in terms of oxygen. So we will be ignoring the hydrogen and oxygen, and we'll be following the other atoms, that is manganese and chlorine. So let us see where manganese went. Manganese formed MnCl2, right? So manganese dioxide is losing the oxygen. So we say it is losing oxygen. So whatever loses oxygen is getting reduced, right? And 4HCl, what is it getting converted to? 4HCl is now we are not following hydrogen, we have to follow chlorine. So let us follow chlorine here. Chlorine, some of it goes to MnCl2, but some of it is going here, forming forming molecular chlorine. That is, it is removing the hydrogen. So here we say for the formation of chlorine, hydrogen is being minus H. This was minus O and minus H. Removal of hydrogen is oxidation. So did you see, for this question we used two different definitions. Now how do you explain this third product, the formation of water? Now hydrogen, removal of oxygen, both hydrogen and oxygen are being removed. So in the products, these removed atoms of hydrogen and oxygen combine to form the third product as a byproduct, that is water. But whatever is getting oxidized and reduced, you have to see from the atoms which are neither oxygen nor hydrogen. So whatever got reduced would act as the oxidizing agent, and whatever got oxidized would act as the reducing agent. So I will write 4 more problems to explain this further. Let us now solve 6 more equations and identify the oxidizing and reducing agents in them. Now the next question is, copper combines with oxygen to form copper oxide. I would like you to pay attention here that there are 2 reactants and there is 1 product. So this is also a combination reaction. Whenever you are trying to solve problems, try to use your knowledge of the other kinds of reactions that are present. And many a times a reaction cannot be defined only in one way. It may not be just a combination reaction, it may not be just it may be a displacement reaction, it may be it may be a redox reaction along with something else. So always keep all the definitions in mind, so that gives you a better idea of all chemical equations. Anyway, coming back to redox reactions, this is copper and oxygen. Copper is turning into copper oxide, and oxygen is also turning into copper oxide. So using our definitions, copper turning into copper oxide, what is happening? Addition of oxygen. Addition of oxygen is oxidation, right? If anything is getting oxidized, logically the other substance should get reduced. So oxygen is getting reduced, we do understand this. Yet there is another definition of reduction that you should understand here. In the case of oxygen, oxygen itself is responsible for oxidation or reduction. If it is adding, then it is causing oxidation. If it is getting removed, it means it is getting reduced itself. But in this case, oxygen is turning into copper oxide. So we have to use oxygen itself is the substance getting oxidized or reduced. So it means, what definition do we use now? We go to the next definition, that is of metals and non-metals. I told you that anything to which metals are positive, just like hydrogen. So anything to which metals are added, that would be reduced. So addition of metal atom. So copper is adding to oxygen, so addition of metal atom, this is the definition you will use here, is getting reduced. So oxygen is getting reduced. So if this is oxidized, it is the reducing agent. And if this is reduced, it is the oxidizing agent. Right? Now we have copper oxide and hydrogen giving us copper and water. Again, follow the non-hydrogen, non-oxygen atom, copper. First thing would be to follow copper. Copper oxide is turning into copper. It is losing oxygen. If it is losing oxygen, it means it is getting reduced. On the other hand, hydrogen is forming water. It means to hydrogen, oxygen is being added. Since oxygen is being added to hydrogen, hydrogen is getting oxidized. The substance reduced is the oxidizing agent, and the substance oxidized is the reducing agent. Next problem. SO2 plus 2H2S will give you 2H2O plus 3S. Now we don't have to bother about the stoichiometry, that is the number of molecules. Our concern is the formulae. SO2, where is the S going? So SO2, is turning into sulfur here, right? So SO2 is losing oxygen. Sulfur dioxide is losing oxygen here, so minus O, it means it is getting reduced. If it is getting reduced, obviously H2S is getting oxidized. But what definition would be used here? In the case of H2S also, the product that we get is sulfur, because we have to see the atom other than hydrogen or oxygen. So H2S is also is losing hydrogen to form sulfur, and loss of hydrogen is, what is it? It is oxidation. So did you notice that in this equation again I used two different definitions to explain oxidation and reduction? So you have to keep all the definitions in mind, and whichever one you find is appropriate, that is the one you will use to explain it. But the easiest way is the first thing to identify the first reactant. The other one obviously would be the opposite. So this got reduced, and if it would be the opposite, you have to find how is it opposite. So you have to find what is the reason for its being, if this is reduced, then what is the reason that this is oxidized. So if this is reduced, this is the oxidizing agent, and if this is oxidized, it is the reducing agent, right? The next equation is H2S plus iodine gives you twice Hi plus sulfur. Now, there is no oxygen, so we are dealing with hydrogen. Which definition are we handling here? Hydrogen. So move with sulfur. Where did sulfur go? Sulfur, H2S formed S. So what happened? There was a loss of hydrogen. Loss of hydrogen means it is getting oxidized. Loss of hydrogen is oxidation. And iodine is, what is happening to iodine on the other hand? It is gaining hydrogen. And gaining hydrogen is reduction. So iodine gets reduced, H2S gets oxidized, and the substance that gets oxidized is the reducing agent, and the substance that gets reduced is the oxidizing agent, and that's done. Next question. You have 4 sodium atoms combining with oxygen to give you Na2O. It's a combination reaction again. And here, did you see? Yes, this is a displacement reaction too. Iodine took the place of sulfur, right? Do you notice here? Iodine took the place, H2S was sitting, sulfur was sitting next to hydrogen. Iodine said, no, that's my best friend, you just move away. So iodine came, pushed sulfur out, took its place. So it was a displacement reaction as well as a redox reaction. And this is again a combination reaction. So you have 4 Na plus O2 would give you twice Na2O. What is happening to sodium? Oxygen is adding to sodium, right? So if oxygen is adding to sodium, it means sodium is getting oxidized. And what is happening to oxygen? Sodium is adding to oxygen. It means a metal is adding to oxygen, which means metal is positive, and therefore addition of positive charge means it is getting reduced. So this is the reducing agent, and this would be the oxidizing agent. Now this is a question from your NCERT textbook exercise. The question is that 2PbO solid, now they've given you the physical state along with it. So you are not supposed to get confused by the physical state or the conditions of the reaction or the number of molecules when you are identifying the type of reaction, because here you're only focusing on what reactant is turning into what product. So here you have PbO, our focus is only PbO, not the 2, the carbon, the Pb and the CO2. PbO is turning into Pb. So what has happened here? Oxygen is lost, right? If oxygen is lost, it means PbO is reduced. What happened to carbon? Carbon has gained the oxygen. Do you see here? It has formed carbon dioxide. So addition of oxygen is oxidation. So this is the reducing agent, and this is the oxidizing agent. This is first thing that you should do when you get a chemical equation. Now, what is the question? The question is, the following statements are given. Which out of these are incorrect? So let us see. We already know what oxidized, what got reduced, what's the oxidizing agent, what's the reducing agent. So now let us see what matches with our answer. Lead is reduced. Lead is in the product. The product cannot be reducing. We are talking of reactants, so this statement is false. Carbon dioxide is getting oxidized. Again, we do not have carbon dioxide in the reactants. This statement is wrong. Carbon is getting oxidized. Yes, we did notice that carbon gained oxygen and it got oxidized, so statement C is right. PbO is getting reduced. Yes, PbO is getting reduced, so C and D are the statements which are correct and A and B are the statements that are wrong. So this was about identifying which substance is getting oxidized and which is getting reduced. Now there are two examples of redox reactions that we see in real life and that cause us, which are undesirable. One is the corrosion of metals and the other is rancidity of food or oils. Corrosion of metals is that we have metals like iron, all metals, copper. They tend to react with the atmosphere and they tend to react with moisture, carbon dioxide present in air, and sometimes they react with acids present in air, and they result in these reactions result in the oxidation of the metal. And when the metal gets oxidized, it either spoils the look of the metal or it slowly starts turning into a powdered product which falls off. So we know iron, in the case of iron, iron gets rusted. And when it gets rusted, what is actually happening is that iron is getting oxidized. And when iron gets oxidized into its oxide, that is iron oxide, it results in the formation of a brown, reddish brown powdery substance which is called rust. And this rust keeps falling off the metal, and as it keeps falling off the metal structure that you have becomes weak. We make so many bridges with iron. There are so many places where in all construction work we use iron, and if it rusts, if it reacts with atmospheric oxygen and moisture, it is going to get oxidized and result in the formation of rust, which will turn into a powder, so the bridges can collapse, the buildings can collapse. So we need to protect our metals from this corrosion. So how do you do that? You either paint the metal so that it doesn't come in contact with the atmosphere. So have you seen people oil painting their iron gates or the fencing that they have? They paint it. Why do they do it? Because we do not want the metal to be exposed to air in order to get corroded. Then we have the Ashoka pillar in Delhi, and that pillar is very, very old and it has not corroded. And why has it not corroded? Because it has been mixed with other metals to form a mixture which is non-corrosive. So this process of mixing different metals in order to improve their quality and in order to increase their life or to improve their looks is known as alloying. You have seen nickel chrome steel, the steel that you have which has the motorbikes and all, they have those shiny handles. Those are made up of nickel chrome steel. So steel is nothing but iron which has been mixed with other metals to enhance its looks, to make it stronger, so nickel and chromium are added in nickel chrome steel. So there are different ways how corrosion can be avoided. That is one example of oxidation redox reactions which are undesirable. The other one that we commonly experience is the food that we eat, fried foods, especially the mixtures that we get from the market. After a little time, they turn rancid, the oil starts smelling dirty. That is where the oxidation of the oil has taken place. And that spoils the food. So in order to avoid that rancidity again, what is done? The chips that you get, the Lays and all, they are packed in packets which have got nitrogen filled in them. And this nitrogen, why nitrogen? Because nitrogen is a pretty inert gas, and it is 78% of air is nitrogen, so it is available in abundance, yet it is quite inert, so it does not allow the chips to come in contact with oxygen, and therefore the oil in the chips does not go rancid. It does not get oxidized and get spoiled. Then there are other ways of preventing rancidity of food. That is, you can keep it in airtight containers. You can keep food in the refrigerator. Why do we put it in the refrigerator? Because at lower temperatures, all reactions become slower. So even the spoiling of food, the oxidation reaction, that would become slower. So the food will live would have a longer shelf life. So that we store foods in cool, dark places. Why? Because sunlight also, if lower temperatures delay the process, the reaction, higher temperatures and sunlight are only going to stimulate the reaction. So we do not want that. We want to slow down the reaction. So these were just some common unwanted redox reactions that occur in our life. This was about redox reactions or reduction oxidation reactions. I hope you found the video helpful and it clarified your doubts. If you found it useful, give it a thumbs up, share it with all your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.